Good evening, everyone, or good morning, or good afternoon. I know some people are in different time zones. We have people from all over the world. I can see people from Europe here. I can see people from the United States, but we have people from all over the world. But what we're going to talk about today, Prabhakar, if you can bring up the website, is we're going to have a deep discussion about translating the fundamental philosophy that food is medicine to the reality of food as medicine and supporting. There's some incredible manufacturers, a lot of small businesses, mom and pop shops are very, very dedicated to producing really healthy products that are, products that are consciously done. They're coming from ethical sources. They're non-GMO, organic. They have high bioavailability. Anyway, a lot of things. So I was honored to be selected as the scientist who was called in to help create the raw and clean food standard. It's a whole thing that because of my interest in this field from growing up in India and having a deep appreciation for clean food, that I helped create the standard. And I'm going to walk you through how we came across the standard, the systems approach we took to create the standard, and why it's really important for the world. But the fundamental notion is food is medicine. So let me begin by first of all pointing you to this website that we have. And this website, you notice it says certified clean, certified raw. Those are the two seals. If you go to different health food stores, different farm stands, or different stores, large stores, you will see the seal on different products. And what does the seal mean? That's what we're going to talk about. How did it come into being? But notice it says consensus-based standards for certified clean and certified raw. Okay, consensus-based standards. That's another way of saying it's a bottoms-up standard. So there are two ways that Prabhakar, if you can just go back to video, there are two ways that a standard comes about in the industry. And some of you may know about this, some of you may not. But let me just give you the background. Standards, industry standards exist for all different fields. If you go look at a light bulb, someone had to determine what was a light bulb that was industry supported, and industry specific, okay? And so there are things like that. And there's standards for nearly everything in the world. And those standards are extremely important. Hey, John, can you come in here, please? John, can you come here? Thanks. And those standards are extremely important because they determine the quality of something. If you're getting something, do you actually know if this is, could you make sure that fence is closed? I don't know what it's open. Okay.
Okay.
All right. So these standards are very, very important because you as a consumer, how do you know this is better than this? How do you know what someone is saying is actually true? Okay. Now, there are two kinds of standards in the world. One is a standard that comes top down, where the government imposes a standard, okay? In fact, the organic certification is from the USDA. The government imposed that. It turns out that most standards, in fact, believe it or not, some philosophy in the government is actually like bottoms-up standards, where standards come from the industry. So, for example, many, many years ago, if you look at a chip on a chip in a computer, a chip on different machines, engineers throughout the industry got together and they put together the standards defining the different chip standards, you see, but it was bottoms up. And this has happened in nearly every industry. The bottoms up standards are typically much better, and they're better because you bring in all the different stakeholders, as it's called. So you bring in the consumer, you bring in the manufacturers, you bring in the supply chain people, you bring in experts. And so typically when it's done bottoms up, you have a much better standard than when it's done top down, okay? Top down standards can highly be influenced by lobbyists, right? That's why I want to mention that this is a consensus-based standard. So the story of this goes back in 2012 and 13, there was a bunch of products out there that had to do, they were claiming they were raw. And you may remember this in the mid 90s, late 90s, there was a movement called everyone should just eat raw food, right? Eat vegetables, don't cook them, right? Because you, quote unquote, lose the enzymes. And, the raw food movement was really taking off in mid 90s. So people started putting products out on the shelves and they'd say, this is raw, this is raw, this is raw. And if you went to people and you said, hey, what is raw? Like, can you define it? The quote unquote hippies, well-meaning people, they'd say, well, raw it's vegan, or you can't heat it over 108 degrees because you destroy the enzymes. So there was a lot of religion around this, frankly. And a very interesting incident took place around 2000, in early 2000, mid 2000. Kombucha, some of you may know kombucha is a fermented drink, was at Whole Foods, raw. And there were 16 different kombucha brands. And all those kombucha brands were, one of them had a bacteria issue. And Whole Foods was forced to take all the different kombucha brands off the market, okay? And it was frankly a disaster, not only for Whole Foods as a company, but for all the suppliers of kombucha, because one guy screwed up and it affected all the other people, okay? So there's a very interesting expo that takes place every year called Expo West, and thousands of health food companies show up at Expo West. It's typically in Anaheim, California. So when I was there, people knew of my background as a as a biological engineer. I had been on various standards committees, and people said, Dr. Shiva, we really need your help. Can you help us create a standard for raw food? There's no standard. We have a lot of people just running around saying raw food is this. So anyway, that's how the standard came to be. And I'm going to walk you through that. And then we created a sister standard called clean food. And I'll talk about that. And so what ended up happening was we had the raw food standard, the clean food standard. And by the way, we did it years ago when I came out of MIT. I was very interested in teaching people how to think systems, particularly kids, and use systems thinking in a variety of fields. So I had started a very small, not-for-profit called the International Center for Integrative Systems, really to educate people. And we never really sought donations. We did it. We used to do a lot of free educational seminars for kids, for local people, really teaching them how to start thinking from a systems perspective. But we'll talk about what the International Center is, because that's where within that nonprofit, this is how. So this was really done as a labor of love to really help the world. So let me begin once again. If Dr. Prabhakar, who's my colleague, who's joining here, is also one of the scientists at the International Center for Integrative Systems. Prabhakar, if you can just bring up again the website. So again, if you go to the website, it's cleanfoodcertified.org. And as you can see, the website has both standards, raw and clean. And if you scroll down through the website, when you get a chance, you'll find out all the different products that have been certified across the world. We talk about what it takes. We made this so accessible to every mom and pop shop. We hold regular public hearings. We'll talk to you about that, okay? Because this is a consensus-based standard. Any one of you can join these public hearings and help influence the standard. Now, no one else in the government doesn't really let you do that, okay? Because the lobbyists pay them, but this is bottoms up. We had a very nice article several years ago in one of the consumer magazines talking about what is a raw and clean standard. Anyway, this was really developed bottoms up by the industry and the leadership of myself and Dr. Prabhakar here, okay? So let's go to the slide set. So that's a little bit of background, okay? So let me now really talk to you about, Prabhakar, can you go to full view, please? Thank you. So we have some slides here. So first of all, some introductions. We have the International Center for Integrative Systems. It's located in Cambridge. Now, I did this because I really wanted to build sort of a research center that really taught people to think from a systems perspective. A systems perspective is where you don't just look at the parts of a system, you look at the whole, holistic. It's much more developed than holistic because there's systems principles. So we do research, we do publications, and we support systems thinking at the local level as well as the global level. Next. So the International Center for Integrative Systems, again, I created right out of when I finished MIT, because I really felt MIT wasn't doing its job to really support systems thinking. So we're organized. We have a board of directors. We have an executive director. We have 3 major projects that go on. One is Innovation Core, where we really have really understood the systems of innovation. You know, innovation can occur anytime, any place, anybody. You don't have to go to MIT to innovate. So every year, our center funds 8 to 10 kids, where we give them money, and we support their efforts to become innovators. I actually mentor kids. If you know anyone, we have applications open for our innovation grant, and people should apply for it. Okay. Next, the other part of the center is we do a lot of research on the systems biology of genetically engineered foods. And we were the first to expose that genetically engineered foods destroy the plant at a very fundamental level. And that was groundbreaking research we did between 2012 to 2014. In fact, it was 6 papers that we wrote. Prabhakar, while I'm talking, you can bring up the final paper. Oh, here we go. So we donated CytoSolve to the center to use for no cost. And we did 6 papers for the world to really understand what happens when you genetically engineer food. And particularly, we looked at soy. Soy is one of the most genetically engineered foods on the planet. And we used our technology, CytoSolve, to really look at every paper that had been written in the world on this. And we extracted out the molecular pathways. And then we went through the process of understanding the plant's molecular system. And then, lo and behold, we found out that when you genetically engineer, in this case, we looked at soy, you actually destroy the soy plant, and the plant actually will start creating or creating formaldehyde and lessen glutathione. Glutathione is one of the most important antioxidants. So this was in the series of 6 papers. This was that final paper. So what you see here, I don't know if there's a zoom in on this, but we had experimental results from a group in Leeds, London. Prabhakar, maybe you can zoom in on that slide. But what we did, yeah, there you go. So you see the first is the experiment. So we, using our technology, which is modeling on the computer, we had found that an organic soy plant would have 9.7 units of glutathione, which is a very, very important antioxidant. As you age, glutathione levels drop. And then we found out that in the Roundup Ready soy, which is Monsanto's soy, by the way, unfortunately, people like Hillary Clinton support Roundup Ready soy. They support GMOs. Interesting enough, a guy called Booby Kennedy actually endorsed Hillary Clinton, who also supports GMOs. Okay. So, but what we discovered at a very scientific level is that the soy plant will have nearly 249%. Prabhakar, maybe you can just point to that, less right there in the second line there. And that was our work. Okay. And we had published that. And when we had published that, we got attacked by the Monsanto lobby saying, oh, this is just a computer model. None of it's true. And Prabhakar, if you can kindly bring up that paper in a window, which that in silico paper, and and you can bring back video while you're setting that up, but Dr. Prabhakar will bring up that video. I want him to show you the actual paper. So this was in 2013. Our center had really discovered at the molecular systems level, what happens when you genetically engineer a soy plant, that the soy plant essentially goes into, from our analysis, what's called oxidative stress. And the plant uses up if it's glutathione levels here, it drops to here. It drops to a new set point. You call it a new allostasis. It's not in homeostasis. The plant's actually it's been weakened, okay? So that's what we discovered. And we put that final paper out. We were viciously attacked by the pro-GMO organs of power. I went to Washington. I did a Washington press conference. We shared all of our research. And Joe Rogan had the opportunity to have us on. And meanwhile, Joe Rogan was putting on people who were pro-Monsanto. And here we had done, and by the way, this is what Dr. Prabhakar is sharing with you here, this is the final set of 6 papers. And this must have gotten like 100,000 downloads, but we said in silico analysis and in vivo results concur, glutathione depletion in glyphosate-resistant GMO soy, advancing a systems biology framework. So Prabhakar, let's go down to where we show the whole system. My co-authors in this were Michael Hansen, John Fagan, and Dr. Prabhakar. So let's go down to that. So we take a systems approach. We connect the parts, right? We like to look at the whole. So in this paper, what we did was we had connected right there a very important molecular pathway in all plants metabolize carbon. They synthesize methionine. They go through a methylation cycle, which creates formaldehyde, which is a toxin. But the plant has an amazing way of detoxifying that formaldehyde, okay? So this was the first paper we had published, right? Paper 1. Next. And we had mathematically modeled it. Next. As we go down, you will see that we had taken that paper right there and we had shown what happens when a plant undergoes oxidative stress. So by the way, when plants undergo a drought, right, not enough water, the oxidative stress pathway on the left side will kick in. And guess what happens? In that case, glutathione levels will drop because a plant is trying to survive and it's using up its glutathione. So formaldehyde levels will go up, and we modeled that. And the final paper, we had shown what happens when you genetically modify plants, which is as Prabhakar goes down, figure 4. And that was genetic modification. We found it was genetic modification plants puts the plants into stress. Next. And then what we had discovered as we concluded in this paper is that we use CytoSolve, this very powerful technology I developed so we can eliminate the need for animal testing. And we had discovered all the molecular pathways that were involved when a plant undergoes modification, okay? And we plugged all of those into our pathways, okay? And including what happens when the plant gets Roundup. And so it's a whole systems model. And we notice here is glutathione levels drop. So the plant is using up its glutathione because it's under a stressful condition. And that's what we showed right here. And in fact, it reaches a new level. Go down, Prabhakar. And now what we did here was, again, when we put this up, people said, oh, this is not true. This is just a computer model. We were very lucky. Prabhakar, zoom in a little bit on this, or you can go back to your slide. And this was a final point, is that we were very fortunate. A group in London, in Leeds, had actually done research. And they had found that glutathione levels in a soy plant were, again, 260% less. So you see our results concurred with the greenhouse data. But more importantly, we knew why. We knew the system's reason. So that's another big piece of research our center does. Next. Now, the clean and raw standard is a third big mission of our standard, of our center within the International Center for Integrative Systems. And again, as I mentioned earlier, the way the standard came out was that there was a serious problem around 2010, 11, where there were all these products being called raw, and no one knew what the hell raw was. So I was called in and I brought in the 30 different industry manufacturers, and I brought them into a room. And we really, it's very interesting. What happened was, Prabhakar, if you can slightly go back to video shortly. What happened here was something fascinating, and I have to explain this. So the problem with good meaning people is they may have some good ideas, but they don't have the science to understand it. So sometimes they make outrageous claims. So the raw foodists at the time, people are just promoting, just be vegan, just to eat plants. and don't cook them over 108 degrees. These people were saying that if you, a raw food was defined as anything that you didn't heat over 108 degrees. And the claim was if you heated something over 108 degrees, you destroyed the plant. All right. Now, many traditional cultures, just to give you the background, do not, like if you go to India and China, rarely do they eat like a raw salad. Why? Because the salads have parasites in them. So many traditional cultures will do some type of processing with food. They'll either slow cook it, right? They don't want to destroy the nutrients, steam it, okay? So they'll do various kinds of things to protect the food, but at the same time not overkill it, right? But here you had the raw food is saying if you heated it over 108, it was dead. So over a period of it took us about a year, we did many public hearings. We had people like many of you here, individual manufacturers, and I literally got up on a whiteboard and we said, hey, what do you think? What is your definition of raw? Someone said, oh, it has to be vegan. And someone said, it has to be plant-based. Other people said, you can't heat over 108, and so on. It has to be sprouted, right? It has to be living. And then it was like herding cats. Again, we want to be bottoms up, consensus-based standard. Over a period of about a year, we all came to a very powerful systems conclusion. And that's this slide here. It took us about a year to get through to this. And as Dr. Prabhakar shows in the slide, we all agreed, consensus, right? Prabhakar, can you show that slide, please? What we ended up showing was that everyone agreed that we could all agree that something raw, and we'll come back to clean, was something that had these three very important factors. It had to be safe, which means obviously you don't want to eat something and it's got mold or garbage, it's got poisons. To give you an idea, if you take kidney beans and you sprout them and eat them, it can kill you, okay? Not everything raw is good for you. Food is medicine. Food is medicine. So things have to be safe. You can't have a certain amount of bacterial load. So it had to be safe. So everyone said, yes, we had it safe, right? All the retailers wanted it safe because imagine putting out food and everything's unsafe and then you have to recall products. The second thing was they wanted the food to be, we all agreed, minimally processed, right? Minimally processed. And then we wanted bioavailability of nutrients. So just look at these three things, okay? We all agreed, all these different industry manufacturers, we said, yes, we want safety, we want it to be minimally processed, and we want it to be bioavailable. Now, remember, our standard that we were developing was really from farm to table. Organic is just looking at how it's grown. Non-GMO is just looking at whether it's genetically engineered. But we wanted to build a new standard on how it was produced and how it was delivered to you, okay? Safety meant how it was processed. Was it done in kitchens with rats running around? And believe it or not, I'm not going to name who the manufacturers were. Because there was no standard, there were people making kale chips. And they literally had rats and rat shit in their facilities. So when you don't have a standard, you don't know what you're actually eating, okay? So safety is important. How is it produced? From the time you bring in the supply, is it in a clean environment, right? Are you producing it in a way that it's following what are called standards? There's health and safety standards, right? So safety was important. Are you creating a bacterial load on it? Minimally processed means, are you cooking the hell out of it? Or are you maintaining the processing so you have high bioavailability? So this is what we came to. And everyone was very, very excited because now we had a scientific framework for defining raw. Next. Then what we had to do was we took the word raw, Prabhakar, go back, and everyone is using this term. So we had to almost re-engineer the term. So we called it real, alive, and whole, R.A.W. Real, alive, and whole. And we had to now come up with a metric. Let's say each one of you listening is starting your own company and you're making different products. How would you get certified raw? Okay. How would you get certified raw? And by the way, JC Denton says, share this everywhere. Okay. everyone needs to know that we have now a standard for really defining what is, truly clean and raw food. Okay. So what we did was we said, okay, we have real, alive, and whole. And the standard was you have to come up with metrics, numbers. So we decided that if you got 80 out of 100 points, you would be certified raw. 80 out of 100 points. So how do you determine the points? Well, we went around, again, consensus-based standard. It's not me dictating to people. I facilitated the systems approach. And notice it's a systems approach. It's not any one thing. So under real, everyone unanimously agreed next that they wanted it had to be safe and non-GMO. And so if your facilities weren't safe, if you didn't, you got a 0. If it was safe, you got 25. How did we determine it's safe? Well, to determine safety, we have independent people. There's all these very interesting standards that have existed for 50, 60 years and how a kitchen needs to be maintained. So people had to give us that paperwork. They had to prove to us that their facilities were properly maintained. All right. So if they weren't, you got a 0. If they were, you got 25. And the ingredients that you were using had to be non-GMO. That means not genetically engineered. So this was unanimous. Everyone wanted that. In fact, they wanted this more than organic, believe it or not. They definitely wanted things to be non-GMO. So if you got safe and non-GMO, you got 50 points. Remember, you had to get 80 points. So if one of these were off, you'd be below 75 points, right? Or 80 points. So you'd lose. So you had to be safe and non-GMO. You got to score 50. It was a mandatory criteria. Next. The next criteria was alive, enzymatically bioactive. Now, here's a problem. Many of the quote unquote fanatics, well-meaning people again, they were saying that anything alive you cannot heat it over 108 degrees. The food is dead. And I had to put my hat on as a scientist, as a biological engineer, as a chemist, as a systems scientist, and say, is this true? Because I could have easily, wanting to be popular, saying, yes, 108 degrees, everything's dead. So what we did here was, because we have a very powerful technology called cytosolve, we came up with a standard again. What we did was, and let me walk you through this. Let's go to the next slide. So one of the guys who was on this committee, one of the standards guys, was a guy called Brad's Raw Crunchy Kale Chips. Now, his kale chips include raw kale, which they add different things to it, like sunflower seeds and cashew and chickpea miso, Himalayan salt, jalapeno powder, cayenne powder, lemon juice, and water, red bell peppers. A very tasty product, and they dehydrate it, okay? And the issue was this, what was the availability of these nutrients, right? So what we did was we analyzed it. Next. So for each of those ingredients, per the standard, you take the top 3 to 4 major molecules by weight. So kale has vitamin C, beta carotene, lutein, and zeaxanthin. Red pepper has capsanthin, capsorubin, beta carotene. Sunflower seeds has ferulic acid, caffeic acid, rutin, chlorogenic acid. Cashews have zeaxanthin, lutein, and anacardic acid. Lemon juice has, areocitrin, vitamin C, and hesperidin. Jalapeno peppers have capsicum. Chickpea miso has raffinose, stachyose, cisaritol, and cayenne powder is capsorubin, capsanthin, beta carotene, as well as zeaxanthin, lutein. Prabhakar, I think we're missing one there, right? On that one?
Yeah, let me just.
Yeah, I think
there's one ingredient here that.
Yeah, there's another ingredient. Okay, I think it's the jalapeno powder, right?
Jalapeno.
Yeah.
Yeah.
So if you can just add that as we're doing it, it'd be good. Just to be complete. So the jalapeno pepper has those items in it. Okay. So we were able to look at each of these molecules, and there's an interesting phenomenon in biochemistry called denaturization. So what we did was for each of these molecules, when something denatures, I'll give you an example of denature. If you take an egg and you crack it in the morning, the yolk you can see through. As it heats, it becomes white. the conformation of the molecule of the avidin in the egg white actually changes. And that changing is called denaturization. And obviously, if you denature it at different points, it no longer becomes absorbable by your body, okay? So what we did was we took each one of these ingredients per the standard that we developed, and we calculated what's called a bioavailability curve. And this was one of the innovations we did next. So what you see here is you see the processing temperature on the x-axis, because remember, they would take the kale chips and they would dehydrate them in dehydrators and these are the different dehydration temperatures. And the y-axis is bioavailability. Now, if you listen to the raw food religious people, they would say, well, if you heat it over 100 degrees, the food is dead. And you can see here, if Prabhakar points to it, if you go to about 120 degrees, it's still about 90 to 100% bioavailable. As you heat it more, it goes down to 80% bioavailability, all the way up to about 150 degrees. And then it has another transition. It drops to 160 down to 220. The point is, the food is not just dead. It's not like 1 or 0. And this is what the raw food community was thinking until we came into the picture. So we started building bioavailability curves for different products, quite valuable. So for example, Brad's kale chips realized, well, we can increase our temperature to 140 and get more throughput, still produce good food. We're not at 100%, we're still at 80% bioavailability. So people can run their businesses, and so if you go to 80%, the bioavailability got 20 points. So 80%, and they were heating their temperature to 140 degrees. So 80% times 20 points for the Prabhakar, go back to that slide so they know how many points there was. Go back. So you got 20 points. So if you're at 80% bioavailability, you would get 16 points. So if you got 16 plus a 50, you'd be at 66. Okay, you're still not at 80. Okay, but this was we thought it was quite a powerful next that we had actually built a mathematical way to calculate the food's bioavailability, and every product will vary. Next, the final thing we did was whole, real, alive, and whole. So we had 2 metrics for whole. Organic. Remember, not all foods can be deemed organic. Some people are growing wild stuff, and the organic, USDA organic doesn't go certify that. There are foods like bees, honey, that people do a lot of work to make sure that the honey is done really well. But the standard is that within a 3-mile radius, you can't have any pesticides. Very difficult to prove. Yet, what we found out was if you looked at some of the honeys that were rated organic by USDA organic, and you took these other bees' honey, and we looked at the chemical stuff, in fact, the stuff that wasn't organically rated actually had less chemical pesticides than the ones that were organic. So we realized we needed to give a range. So organic was 0 to 20 by weight. So that was an important point. And then we had nutrient density. We used the Andy score that you can look at the density of the food. So this would give you another 30 points. Okay. So if you only were 50% on each, you still got another 15 points plus your 16 from the alive, which is 31, plus your 50, and you would make it to 81 points. There you go. So this next slide. So this was a raw and clean standard, and I just walked you through an example. So that's raw and clean. Now, given it was a consensus-based standard, next slide, we had a huge open public hearing. Oh, okay. Prabhakar, can you go to the actual standard, please? The actual document. The document really is there. No, yeah. So what we did was we had produced, by the way, this is a formal document. We are actually a member of the American National Standards Institute. I can't tell you how much work it did to do this. This was, again, done by a labor of love. Neither Dr. Prabhakar or I got paid a penny for this, okay? Neither did any of the people. This was done by people who really cared for the world. And what we did was this became the standard, and every year it's updated. But we presented this in a room for about 200 people with all the industry manufacturers at Expo West. And everyone unanimously supported it. But there were some people in the room which said, hey, look, I heat my food beyond, and by the way, the heating temperature was 212 degrees. There are certain caveats here. Nuts coming into the United States, all nuts coming into the United States, believe it or not, have to be flash pasteurized by US law. So it means they dunk it very quickly to remove any mold or pesticides. But what's fascinating is you can even take those nuts and they will still sprout. So they're not dead, okay? But they're done in a flash pasteurization. So we had to support some of these very realities in the United States, for example, or for different parts of the world. So everyone was very excited for various reasons, because now we had a standard what raw meant. No one had done this in the world before. But there are some manufacturers that said, hey, look, I produce spaghetti. I produce different foods, and I heat them over, more than 212, not for long. And they didn't want the raw nomenclature, because some people may think raw meant like raw meat, right? You have worms in them. So we created a sister standard, and Prabhakar goes back to it. We created a standard called C.L.E.A.N. And C.L.E.A.N was all the same characteristics, but it meant conscious, living, ethical, active, and nutritious. Conscious being the safety parameter, 0 to 25. Living being the score for organic, 0 to 20. Ethical meaning non-GMO, 0 or 25. Or, you say, active meaning 0 to 20, bioavailability, nutritious, 0 to 10. By the way, the conscious safe was 0 or 25. But you could heat it over 212, okay? Some of the nut bars are like that. Next. So this resulted in a same mathematics. So there were some products which were raw and they were clean, right? So for example, Hail Marys, these dessert products are both raw and clean. Next. Next. Thanks, Prabhakar. And they use them based on, from a marketing purpose. If they're on an airplane in certain countries, no one knows what raw means. They will push the clean label. But places where people are they understand raw food, they'll use a raw label. But in this case, it's both. Prabhakar, you may just want to show Artisana, for example. Artisana is a very interesting company. If you go on the nut aisles, this company literally farm to table. And by the way, what we've done now is we've created a bottoms-up community of manufacturers all over the world. So when one manufacturer signs on, everyone supports each other. So Artisana on their thing really supports, as a part of the community, certified raw and certified clean, okay? And different people do it. You can find various products that are out there, okay? Household products, but they're at a very high standard. They're beyond just organic. They're beyond just non-GMO. They have to fulfill these 5, really good housekeeping seals of approval. Okay. And next, so now we wanted to make this affordable, because there were companies which were, a single mom would start a company, right? And she's not making a lot of revenue a year, maybe $10,000. And there were other companies who are making $100 million. So part of you can zoom in a little bit, Prabhakar. It's very hard to read that. We wanted to make the standard affordable to anyone on the planet, small or large, a little bit bigger, Prabhakar, and double the size. So we created a way that we could accommodate many, many people. And in fact, when I show you the pricing of this, people say, are you guys charging enough? Again, remember, this was for a labor of love. So if you're a company, and let's say you're producing a bar, and you want to find out, I want to get the raw and clean. So we would ask you how many manufacturing sites you have. You say, well, I'll make it in my home kitchen. So that would be one. And we typically ask people how many products that you're doing. Someone may be doing 3, let's say, bar products. They use, maybe they have a cashew product, almond product, and they have a pistachio product. Okay. Meaning they mix, let's say, cashews, oats, and honey. The other one mixes almonds, oats, and honey. And the third one is pistachio, oats, and honey. These bars. So that would be 3 products, Prabhakar. And then what we wanted to do is, because we were trying to keep it affordable. In that case, with those 3 products, they actually have, if you think about it, really 2 common ingredients, the oats and the honey. And then they have 3 unique ingredients, right? They have 5 unique ingredients. we didn't want to double charge them for each product. So you would put 5 there, right? You have the oats, the honey, common among all products, and then the almonds, the pistachios, and the cashews. Okay, so that would be 5. So you're producing 3 products with 5 unique ingredients, and then we'd ask the person, how much revenue are you generating? So let's say it's a company that's only making $100,000. So let's put 0.1. Okay. So if you do 0.1, you would pay $127 for both certifications for each of your products. Okay. For one certification, you would pay $102, but for all 3, you'd pay $382 if you wanted both, and $306. So we are basically giving a scholarship. Now, watch what happens if the company grows to $10 million in revenue. So as your company grows, you contribute more. Okay. So there you go. So, and we literally developed a curve. So it was really all for one for all. The big guys support the small guys. The small guys get to grow. So we had really nailed it, right? We had created a very holistic standard. We had created a way that anyone could participate. We had a woman who had a $10,000 revenue company, right? And if you go down on the curve, we literally built a curve that it's basically a handicap, right? Scroll down, Prabhakar. So if you were making less revenue, the factor was less as you produced more revenue, okay? And everyone seemed fine with this. Go up, Prabhakar. That's how the pricing worked. Back to the slide, Prabhakar. I don't know if we have any other slides left. So is there any other slides, Prabhakar?
We can show some of the changes that we made.
Yeah. So every year we do public hearings, and all of you are. So this is a living standard. As I mentioned, as many of you know, I'm into bottoms-up movements. This is a bottoms-up movement. So recently we had a lot of the hemp and the CBD people. So now we've also included CBD and hemp-based products. We've also excluded a non-certifiable ingredient from the organic criteria, like minerals. Next. The acceptance of the pesticide, herbicide, fungicide data for whole criteria for certified raw and live has also been included. Why? Because remember, what we found was there's some amazing products where people can't afford the organic certification. But if they give us the pesticide, herbicide, and fungicide data, and it is at the right numbers, right, that it doesn't have the herbicides and the fungicides, right, these are like glyphosate, we will still certify them as raw. So the benefits are, we're finding it's much more stringent. In fact, it's more inclusivity. In fact, if the levels of the pesticide, herbicide, fungicide in a product are below EPA and or the USDA NOP guidelines, that should satisfy whole and live criteria. Now, this could be more applicable to products such as maple syrup and honey. And let me explain this. Prabhakar, is there any other slides here? Yeah. And I'll come back to that. I want to explain that. And then the other change we did was we also do dietary supplements. Now, for dietary supplements, we removed the Andy score because it didn't really make sense, nutritional density in a supplement. And that's only required for fruit and vegetables now. Next. We've also now recently on the clean side included animal-based products. So that means ethical treatment of the animal, safety of production environment, alternative nutrient density criteria, and the other Andy score, and how the animals are treated. Are they factory farmed, which wouldn't make this certification? Next. And there you go. Thanks, Prabhakar. So let me talk to you a little bit, if you can go back to the video. I mentioned something about this criteria about honey. What's fascinating is we had a number of maple syrup producers who wanted to get it clean and raw. And what's fascinating is there in Vermont, where people grow, where there's maple trees, you could have a particular supplier who's organically certified, right? Because he's growing everything in his soil. But there could be someone else up the hill who's putting pesticides. And when that streams down, the organic certification wasn't capturing that. Okay? So our standard in some ways became more stringent because if someone couldn't get the organic certification, we made sure, could you actually get the actual chemical analysis data? All right. So there you go. So Prabhakar, if you can go back to the website and display that. So we have created a global standard now. Companies all over the world, from Africa to Japan, to India, to the United States, to Brazil, South America, Canada, all of them. And all of this was started bottoms up, not by the government imposing this. That's the important thing. So as many of you know, if you follow the work I do for Truth, Freedom, Health, I'm really about bottoms up. And this is a living, people say, oh, you can't do it. Well, we did do it. We got people to come together, and people came together. We had to do the homework, though. It was a lot of work. But because we did the homework, because we did the science, and it took us a long time, right? But so we've been doing this now for 10 years. But this is a very high quality standard of non-GMO, organic, safety, bioavailability, nutrient density. So there you go. So what I'd like to do is let me take some questions to all of you on the web, on social media. I just want to thank you all for coming. If you want to know more, go to cleanfoodcertified.org. And Dr. Prabhakar, maybe we have some questions from our people. Maybe we can read some of the questions. So I'm going to go to the chat, and all questions are fine. You can ask them. Someone says, what is the cost per year for this certification? So let's again explain that. Prabhakar, if you can bring it up. So the cost is basically a function. Rakesh Reniga is asking. It's a function of various variables. One is, how many facilities are you making it? That's called a plant. So let's say you have one facility. How many products? In this case, we took 3 products. How many unique ingredients across those 3 products? And in this case, we said 5 unique ingredients. And the size of your company. We're looking at a $10 million company would pay for all those 3 products around $1,300, $454 per product. If you look at any of the other certifications, they're like 10 times more expensive. But again, we weren't in it to make money off of it. We really wanted to create a movement for raw and clean food. Now, if that size of the company, Rakesh, maybe your company is only making 1 million in revenue, and if Prabhakar adjusts that number, you will see that the pricing will go down, okay? So it drops by half, $675 for all 3 products, $225 if you want both, and $180. So there you go. All right, next question. Any comments? Don't be shy. Okay.
I have a comment from, I think, Serena Morello. She's asking, heated or sprayed nuts?
What's that?
She's nuts. Serena, if you're still here, if you can clarify that.
What does it say, Prabhakar? What is the statement?
The comment just says heated or sprayed nuts. I think she's talking about the whether the nuts are pasteurized.
Oh, yes.
Right.
So by the way, as I mentioned, nut processing in different countries varies. Nearly all the nuts in the United States are not quote unquote raw, especially if they're being imported, right, Prabhakar? If they're internal, it's different.
Yes.
So when people bring in, let's say, almonds, before they get into the US border, they have to be flash pasteurized. But we did a carve out in our standard because what we found out is if it's flash pasteurized, you can actually take those nuts and they'll still sprout. So they're not dead. It's not like you've roasted the hell out of them. So I think that's what she probably meant.
She also has another question, Serena has. Can you tell me if there is a certificate for commodities such as water, such as like alkaline water, or any other commodity?
Yeah. So I think the question is, one is products. So if you think about a product is made up of many ingredients, and then we also certify ingredients, right? So we've certified, for example, cacao beans, right? The actual cacao, chocolate. We've certified, for example, coconut water, right? We've certified sugar for Zucromex. We could certify water, okay? We haven't done that, but I think we've done coconut water, okay? So water would go through the same process. Obviously, you would look at the purity of the water. And right now, it's interesting you asked that. I don't think there's any standards for water, Prabhakar, if you think about it.
Right.
It's fascinating. It's sort of staring us right in the face, because most of the bottled water you get, you don't really know anything. Another question Rakesh has is, which retailers prefer raw or clean label? So one of the important things to understand is that it's really two things. It is the market, Rakesh. Some people know there are a lot of people are still raw foodists, right? Living raw food. So it depends on if you go to the shopping stores, they have sort of the raw aisle, right? Where they have the kombucha, they have certain raw products. So if you want your product position there, you obviously want the raw. The manufacturers, frankly, if they're raw fanatics, they'll do the raw and the clean. Those people who don't satisfy the 212 degree, they obviously can only do the clean. But it again depends on the retailers and who they're appealing to. If it's a small or medium-sized health food store, they will have a raw section, right? Where they want to promote the raw ingredients, like sauerkraut is, for example, raw, or raw honey, a raw food bars, right? Those kind of things. The next question Rakesh has is, are products that go through thermal process of frying qualify for raw? Okay, so frying probably is going to burn the hell out of the product, and they're probably going to lose on bioavailability. Wouldn't you say, Prabhakar? They would.
It will depend on the ingredient, but I think for that particular product, clean would be a better option than raw, because
yeah, I think a fried food would never make it through raw, particularly because it's heated over 212. Now, you could have a fried or thermally processed food that may still retain quite a bit of its nutrients, okay? For example, certain pastas, right? They could be organic, they may have gone through some heating process, but they're still clean, but they may not be raw. Prabhakar, do we have any other examples of that? I think recently, some vitamins, right?
We did some baked products. They get baked. So, I mean, there is a heat involved in that, but I don't think we have done any fried products.
Yeah. All right, let me see if there's any other questions off in our world of social media. So let me see. Someone's asking, how easy it is to find these certified products, and how widespread are these certifications? That's Monica Lekis. So Monica, what we have done here, first of all, this is a movement for clean and raw food. So what we've done is we've created a network of all these manufacturers. So once a manufacturer signs up, we actually want people to be quote unquote non-competitive, in the sense most of our manufacturers have social media sites, and then we will promote those products. So, I mean, Artisan is a pretty big company. The kombucha products are pretty big. But it's, you don't have, you obviously have, it's a elite certification, meaning it's a certification for those organizations which really care about their customers, and it's growing explosively. But you can find it. Go to Whole Foods. Go to the bar aisle. You'll see clean and raw products. Go to the beverages aisle.
Costco also has some.
Kombucha. Yeah. So Costco Costco, Walmart, Whole Foods, small retailers. So it's pretty widespread. But we do want to say that it's a very high standard. Some Angela Rossi says, why did they spray sulfur dioxide on fruit? You want to answer that, Prabhakar?
I think it is, if I remember correctly, it is either a antimicrobial. It helps them keep the
and it's a preservative
longer.
Yeah, it prolongs shelf life. Typically, that's why they do it. Someone, Hamza Mir, said, aren't seeds bad for your gut? Very good question, Hamza. Look, food is medicine. And what's happened is everyone thinks this is bad or good. So in most traditional cultures, no one would ever eat a raw seed. They would put it in water, soak it for 2 days until it sprouted, when most of the protein is converted to be much more bioavailable, okay? So bioavailability is a key. It's not about good or bad. You can, like I said, you take kidney beans and you sprout them, you think, oh, wow, I'm eating sprouted foods. Well, you'll kill yourself, okay? So just because something's coming from nature doesn't mean it's good, okay? So this is a very important thing we need to get out of this religion, to think, you know, it's good because I ate it so naturally, right? Well, not true. You can eat a lot of stuff naturally and kill yourself. But seeds should be typically sprouted, because your liver, if you eat too many nuts, you're going to have a lot of gallbladder issues, okay? So be very careful with the amount you do. Dosaging is important, and how it's processed.
Sprouting is a better way to eat some of these seeds.
Yeah,
Most of the seeds.
one of the things our center did with cytosol was we recently, in fact, we did it for Two Moms in the Raw, right, Prabhakar?
Yeah.
Prabhakar may, this is, by the way, any of you out there who are manufacturers or researchers, please know that we do a lot of research. We do groundbreaking research. We did research several years ago. There was two mothers who had started a very cool company called Two Moms in the Raw, and they made sprouted nut bars, sprouted almonds, sprouted what? Sunflower, and sprouted oat groats. And they came to us because they had an intuition, well, the sprouted almonds would be better than the roasted almonds, which are most in the foods. Now, in ancient traditional culture, all foods are, particularly nuts, are sprouted, right? A processing takes place. And so we did that research, and we fundamentally showed that a sprouted almond has about 5 to 10 times more amino acids than a roasted almond. Very important research. So Prabhakar, if you can bring up that slide as we close. It's 3:09. We promised 1 hour.
Which line?
The real alive, the minimally processed bioavailability, that slide.
Yeah.
So many of you know, I've shared the story growing up in India. When you grow up in a village, there is no GMOs. Everything is naturally organic. But in most traditional cultures, the slide before this, Prabhakar, the minimally processed, before you went into this. So what I want to show is something fascinating. Yeah, show the slide, Prabhakar, with the elephant. So what I want to show in closing, and if you could bring it up full screen, is that everything that I am interested in getting to real solutions is to not be like the blind men looking at the elephant. So when you look at food, you can say, oh, this is good, that's bad, this sucks, that's excellent. And that's like the blind men. When you look at a food product, you can look at it, oh, this has this nutrient, it must be good. Or this has, it's vegan, it must be good. So that's a blind man, but you have to look at the food from a systems approach. Next slide. And that's what we have fundamentally done. And if you look at this, we literally went back to ancient systems of food, where medicine was treated, where food was medicine. We said, is it safe? Traditional foods, ancient cultures didn't eat unsafe stuff. They did some type of processing. They sprouted it, threw away the phytates, the water. Maybe they lightly roasted it. Maybe they slow cooked it. There's a wonderful food in India called an idli. What they do is, it's in South India, you take rice and you take a very particular dal, and then you mix them together and you sprout them like for 3 days. And then you throw away all the dirty water, okay? And then you grind it. It's a fermented food, amazing for your gut. And guess what? Then you get this, literally, it's not a flour, it's literally what would you call it, Prabhakar? Like a paste, right? A batter.
Yeah.
A batter. And then that batter is put into these very little small bowls, which are then steamed. So you're steaming the food, very healthy, and it's fermented. One of the most amazing foods on the planet. It's called an idli, IDLI. So it's safe, minimally processed, and you have massive amount of nutrients. So a lot of the people say, eat meat, be a carnivore. And the other people say, eat vegan. These people are both sort of numbskulls, okay? Because they're go back to the slide, they're the blind men. So ancient cultures realize, yes, we're going to figure out how to take the rice. We're going to figure out how to take these small beans. We're going to ferment them, and we're going to steam it. It has super high protein bioavailability. All right. So traditional cultures, thousands of years, they use their brain. They use a systems approach. Next slide. So my point in telling you this is what we have actually created is a systems approach to look at food. The government didn't do it. I did it. Our team did it. The industry did it, right? So this is a central point. Thanks, Prabhakar, if you can bring back the video that I want to close on. The power of us coming together as citizens, doing things together, independent of the government, is quite extraordinary. And that's why I wanted to share this with you, because here we have created a standard by the people for the people. I hope you understand that. And this should inspire you guys that we can do amazing things when we come together. And so this was done by customers, stakeholders, the retailers. We all came together. I led the effort and we did it. This wasn't done by some nonprofit say, give me money, give me money, give me money. We did this for nothing. And the little money we made it so affordable, the certification, we put that back into research. So there you go. So I hope, number one, you understand what is clean and raw. It was done by us, by the people, for the people. And it gives you an example of what's possible when we come together and we take a systems approach. And that's why I support systems thinking, right? So get involved. Many of you know we have taken these systems thinking concepts, and on a personal note, I've created an educational environment to do that. Truth, freedom, and health. It's a system. So if you want to know more, go there and check that out. You guys can. We don't even ask for donations for the center, do we, Prabhakar? We should. You guys can support the center, but most importantly, go support these foods, the clean and raw foods. You're going to help a lot of mom and pop businesses who really care about you and care about the world. That's it. Prabhakar, do you have anything else you wanted to share before we close?
I think that's it.
Okay. All right, everyone. This is Dr. Shiva Ayyadurai with Dr. Prabhakar from the International Center for Integrative Systems. And we've just shared with you, Prabhakar, can you just bring up the website again? We've gone through and we've shared with you the clean and raw, clean food certified, raw food certified standard. Prabhakar, if you can just share that video and hold it, and I'll just come back to our group here. Yeah, to the first part on the top, Prabhakar. If you can so just hold it there as I sign off. So everyone in social media world, I hope this was valuable. As I say, be the light.